Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject electrical and electronics engineering. Today we're going to see another problem is in mesh analysis. In previous videos we have already seen mesh analysis procedures, mesh analysis problem, how to use calculator to solve the problems, all those things we have already seen, right? I would recommend you people to go through those videos and come to this video so that you can understand the basics and it will be very easy to understand this problem, right? And today we're going to see another interesting method to solve the expressions. We're going to see Cramer's rule for solving the equations, right? So we will start the video with the problem. So if the question is given like this, in the circuit shown in figure, determine all branch current, find the voltage across the 5 ohm resistor, right? So you need to find out the voltage across this particular resistor, right? So as usual, what you will do, you will find out the equation. How do you write the equation? First thing you have to find out, we have to consider I1, I2 both are in same direction, right? And you always assume I1 is greater than I2. And then you have to assign plus and minus signs, right? So whenever you approach any particular resistor, it is plus, this is minus, this is plus, and this is minus, and this is plus, this is minus. You are approaching this way, right? And now you are approaching this way. This is plus, minus, plus, minus. This is plus and minus, right? Now you can write the expression, right? So you start from this particular point. So if we're going to consider this particular point, it will be 3I1 plus 5I1 minus I2, right? And it will be plus here, right? So it is plus 6I1 and we are approaching minus here. So it is minus 50. That is equal to 0, right? And you go to write, you have to simplify this expression, right? So it will be 3I1 plus 5I1 minus 5I2 plus 6I1 minus 50. We take this 50 that side, okay? So if you add I1, right? So what is I1? So it will be 5, 8, 14. 14 I1 minus 5 I2 equal to 50. Like this, you write the expression for this one, right? So it will be plus. So it will be 2 I2. And we are approaching plus here. So it is plus 25. We are approaching plus here. So it will be plus 8 I2. And when approaching here, it will be minus, right? This plus minus here. So this minus 5 I1 minus I2 equal to 0. So if you if you simplify this expression, it is 2I2 plus 8I2 minus 5I1 plus 5I2 equal to minus 25, which means it will be minus 5I1 plus 8 plus 2, 10, 10 plus 1, 15. 15I2 minus 25, right? can also simplify this by I1, right? I1, 3, I2, and as well as 5, minus 5, right? This is expression 2. You can simplify it and write, right? So this is the same procedure which we have followed here. You can see 14 I1 minus 5 I2 is equal to 50. Similarly, minus 5 I1 plus 15 I2 minus 25. Right? So whatever may be the problem, follow the same procedure which we saw so that you can easily solve it. Right? And now consider this expression 1 and this is expression 2. Right? And you can simplify the equation. Right? So how will you simplify the equation? I'm going to multiply this equation 1 by 3 so that I can able to cancel this equation and I can able to find out I1. If you want to find out I1, it will be I1 is equal to 125 divided by 37. So you will get around 3.378. And if you're going to substitute this I1 in this expression or in this expression, we can able to find out I2, which is minus 0.541, right? And it is negative sign, and we are considering everything in clockwise direction, right? So you can neglect the negative sign, or you can have it same, right? What is it we have to find out? We have to find out the current across this 5 only, 5 ohm only. So how will you write 5 is I1 minus I2, correct? So what is the value of I1? I1 we find out as 3.37, and I2 we have find it out minus 0.541. So it will be I1 minus I2. So it will be minus of minus plus. So it will be 3.914, right? So it is the same procedure like the previous problem, right? So if you are able to write the expression, right, then you can able to solve without any problems, right? Now we will see another problem where we will use Cramer's rules to solve the expression. So here, uh, right, first step what you do, to determine the mesh current I1 and I2, right, they have asked you, and now this is the circuit they have given. So we consider all the mesh as same, I1, I2 and I3. This is I1, this is I2, and this is I3. And you know how to write the expression. So first we consider this as plus and this as minus. Similarly, this is plus, minus, and this is plus, minus, and this is plus, minus, and this is plus, minus. So if you start for this particular mesh, so it will be I1, right? So it will be I1 and I2 here because this resistor is common for both I1 and I2. So I'm writing it as I1 minus I2. If you take this 2, it is I1 minus I3 because it is common for I1 and I3. And this approach, we are approaching this 6 as plus, and whereas here we are approaching towards this side, so it is minus. Right? Same like previous problem. So you can simplify this expression and you apply this. Similarly, consider this mesh alone. C, F, G, C. This alone. So you will write it as 2 into I2, right? Whereas 3 here, right? 3 here it is I2 minus I3, right? You will consider plus sign because they are approaching from here. And similarly, here it is minus, right? So it is minus I1 minus I2, right? So you will put my plus and minus. That is what we have already given, right? And then by simplifying, you will apply this expression. Now consider this mesh DGHE, right? You consider this one. So here already we have given it is starting with minus sign. So I am putting it as minus I2 I3. Whereas here it is, there it is plus I3, right? There is 1 into I3. And we are approaching this one. It is minus here. So it is minus 2 into I1 minus I3, right? This is common for I1 and I3. And again we are approaching minus here. So it is minus 6. So this is the second expression. So third expression, right? And now we can able to solve this expression, right? And since there is equation 3 equations, we can use Cramer's rule. What is Cramer's rule? Cramer's rule, we follow this particular uh, method, that is Zi is equal to V, right? So how do we solve this expression? This expression is same, you can see here. We know that we have I1, I2, I3, so it is I1, I2, I3. The voltage values is given as 106. I've taken 106, right? And these values 3, -1, -2, -1, 6, -3, I've taken it. So this is Z, this is I, and this is V, right? So whereas I can be represented as I1, I2, I3, V is equal to V1, V2, V3, and Z is equal to Z11, Z12, Z13, like this, right? Now, how to solve this expression, right? So it's very simple. First, you need to find out del. Del is nothing but the modulus of this particular matrix. So if you find out the modulus of that particular expression, you will find it out 39. And now we need to find out I1, I2, I3, right? So if for I1, what you got to do? You have to remove this alone, right? This alone, you mention it as V1, V2, V3, V1, V2, V3, right? And like this, you can able to solve. What is V1, V2, V3? V1, V2, V3, we already know what is V1, V2, V3. I106. So instead of this first I1, we use 106. So you can see here, we use 106. These two the same. These two rows the same. These two columns the same. So only this one I'm going to find. I'm going to again find out this particular expression, that is modulus of del, so, sorry, modulus of this one and divided by del, right? And we'll find out 3a. Similarly, for I2, what you have to do, you have to replace this value alone to I2, right? And similarly, for I3, you have to replace this value with 1006. Whereas for I2, this value is replaced from 106, right? So you can see here for I2, I'm removing the second part and I'm using 106. And we're going to find out I2 as 2 amps, and similarly I3. Now what you have to do for I3, you consider this as 106, right? You replace that and so find out the I3 value, so it is 3 amp. So the question given us to find out the current I1, I2, I3, we have solved it. But what we have done is we have used Cramer's rule. So according to Cramer's rule, first thing you have to find out del, right? And then you can find out the current by replacing the corresponding column, right? So today what we have seen is we have seen another problem in mesh analysis where we have used Cramer's rule to solve the problem. I believe this video will be useful for you. Thank you, my dear students.